Module 1, Operations with Integers. This is section 1.5, Adding Integers. But before we talk about adding integers, I want to remind you about two properties. One is the addition property of 0. You can add 0 all day long, as many zeros as you want, and we'll never change that number. So 7 plus 0 is 7, and 0 plus 7 is still 7. Notice that when we change the order here, the sum, the answer to an addition problem, didn't change. That is called the commutative property. So you can add numbers in any order and you'll get the same answer. So if you have three numbers, 1 plus 2 plus 3, that would be the same as 3 plus 2 plus 1. Now that we have that out of the way, let's talk about adding integers. Adding integers can be visualized using a number line. A positive number could be an arrow to the right, and the negative number can be an arrow to the left. And when we want to add them, you will link them from end to end. And then wherever the second arrow ends, that's the answer to the problem. So for example, if I have a negative 2 plus a negative 3, I would start here because here's negative 2. And so this is the line that represents a negative 2, and then I want to add it on. So I'm going to take the end point here and add that on to this arrow for the negative 2. And since this is a negative 3, I have another 3 units heading to the left, and it ends at negative 5. Now maybe you'll notice that 2 plus 3 is 5, and then we have these negatives. And that's going to help us create some rules. If you're adding two numbers with the same sign, all you're really needing to do is add the absolute values and use their common sign. So a negative number plus a negative number, just add them like they were positive, but keep the negative sign. So a negative 14 plus a negative 9, notice these are parentheses, are not absolute value bars, would be the same as adding the 14, the absolute value of a negative 14, and the 9, the absolute value of a 9, which is 23, but the signs are the same. They're both negative, so we're talking about a negative 23. If you were going to use your number line, it would be a little long, but let's move 0 all the way over here. I would have 9 units going to the left since it's negative, and then I want to add on 14 more, also heading left. So I'm going to take that endpoint and link it onto here and have another 14 units. That's heading to the left. So I would have taken 23 steps to the left. It gets a little bit more interesting when you have different signs. You can still use the lines on the number line, but sometimes it gets a little sneakier. What you want to do is find the difference between the absolute values of the two numbers, and then use the sign of the number with the larger absolute value. Not the larger number, the larger absolute value. So negative 11 plus an 18. Well, negative 11 has an absolute value of an 11, and 18 has an absolute value of 18. The difference between these two numbers is 7. But think about it as a tug of war. 18 has a larger absolute value than negative 11. So positive 18 is a stronger number, and so it gets to give the sign. So a negative 11 plus an 18 is a positive 7. If you were using your number line, it would look a little bit stranger. So I have my 0 here, and I have the negative 11 that points this way because it's negative. But 18 is positive, and positive numbers go right. So when I take my endpoint for the 18, it's going to still link here, but it's pointing the other way like this. And so what happens is it's like you made a little number U-turn right here, right? And this, the overlap, gets washed out. And where did you end? Well, if I had 11 negative units and then I filled that hole in, I would wind up 7 above ground, and that's why I wind up at the 7. 8 plus a negative 13. Well, the absolute value of an 8 is a 8, and of course absolute value of negative 13 is 13. The difference between the two is a 5, but now 13 is the larger absolute value. It has more power, so it gets to give the sign, and so my answer is a negative 5. If I had the number line with the arrows, here's the positive 8, heading to the right, but negative 13 goes the other way, so the endpoint would link here, but then go this way. And now it's like you're at the top of the staircase and you came down 8 and then you kept going. So now you're going to be underground, -5. If you have two numbers that you're adding that are opposites, the sum of two opposites will always be 0. So -2 plus a +2 is 0, and 4, or let's say 4 plus a -4 is 0. Opposites always add to 0. If you have more than two numbers, start at the left and start working your way down. 5 plus a -7. Well, the absolute value of a 5 is a 5, and the absolute value of a -7 is a 7. They're opposite signs, so I'm going to take the difference between the two, which is 2. But 7 is the bigger number, right? Bigger absolute value, so it gets to give the sign. So this is going to come out. I'll add those, and now I'm talking about -2. But I got to now add on the 3, and I have -2 plus 3. Well, the absolute value of -2 is 2, and the absolute value of 3 is 3. They're opposites again. Of course, 3 minus 2 is a 1, but 3 has the larger absolute value, so it gets to give the sign, and your final answer to this question is a +1. Sometimes they want you to do multiple substitutions and do addition and subtraction a few times, and so they may give you an expression. 3x plus y. We want to evaluate this. Let x equals 2 and y equal -6. So I'm going to take this x out, and I'm going to put the 2 in, and I'm going to take the y out and put the -6 in. 3 times 2 is 6. We need to still follow PEMDAS and do that multiplication first, since there's no parentheses and no exponents. And now I'll add 6 plus -6. Well, I know those are opposites, same absolute value with different signs, and those always add to 0. And so the answer to this question is 0. Let's look at a word problem. At 4 p.m. on February 2nd, the temperature was a -10 degrees, but by 11 p.m. it had risen 12 degrees. So it started at -10 and then it went up 12 degrees. What is the temperature now? Well, since I have a -10 and I want to add on 12 degrees, I'm adding opposites. So I'm really talking about what's the absolute value of a 10 and the absolute value of a 12, and then I need to find that difference. Well, absolute value of 12 is 12, and absolute value of -10 is 10, so my difference is a 2. The larger absolute value is the 12, so it gets to give the sign. So now it's only 2 degrees. Let's do one more. Evaluate 7 plus 3z if z is equal to a -3. So I'm going to take the z out and put a -3 in. Don't forget PEMDAS. We need to do multiplication first from left to right, since we don't have any parentheses or exponents. And 7 would be, instead of 7 plus 3 times a -3, is going to turn into 7 plus a -9. Now I need to do my addition and subtraction, and these are opposites. Well, the absolute value of a -9 is a 9, and the absolute value of a 7 is a 7. The difference between these two is 2. 9 is the bigger absolute value, so it gets to give the sign. The answer is a -2. 2 times the quantity x minus y for x equals 8 and y equals 4. Well, let's sub in the 8 and the 4. So I have 2 times the quantity, 8 minus 4. Well, those signs are not opposites. They're both positive, so I would just do my subtraction the way I normally would. 8 minus 4 is 4. They're both positive, so it gets to stay positive. So it's 2 times 4, which is 8. And that's how you add integers.